Hello everyone, welcome back to my YouTube channel. Today we will solve a very interesting question from geometry. This question came in CAT 2002. So let's solve the question. The length of the common chord of two circles of radii 15 centimeter and 20 centimeter whose centers are 25 centimeter apart is. So basically we have to find the length of the common chord of the two circles. The radii of the two circles are 15 and 20 centimeters respectively, and the centers of the two circles are at 25 centimeters apart, okay, are at a distance of 25 centimeters from each other. So let me first draw the diagram, so this will make things easier to interpret. So like what will be the diagram, right? So since the two circles have a common chord, so definitely the two circles must intersect each other, right? Without intersecting, the circles won't be having any common chord, right? You can also figure this out by adding the radius of the two circles. Okay, let us say, okay, suppose this is one circle, this is another circle. Okay, and these two circles are intersecting, and we have the centers. This is the center. Okay, if I join the centers of the two circles, just let me join them using freehand. Okay, this is R and this is capital R, suppose. So what is the distance between, they are tangential. Okay, they are tangential, externally tangential, externally tangential. And what do I mean by the word tangential? Tangential means touching each other at only, or you can say exactly, or exactly at one point. Exactly at one point. So why I am drawing this diagram is to make you understand that the distance between the two centers, suppose I denote that the distance is d, so that will be equal to capital small r plus capital R. Okay, now if I add the, as per the question, I have the radius as 15 and 20, right? So the distance between the two centers would have been, this would have been 30 centimeters, right? It would have been 30 centimeters when the two circles are tangential externally, but we are given that the centers are 25 centimeters apart. This is only possible, right, when the two circles intersect each other, then we will have a common part, right? So R plus R is greater than D in our case, right? So 35, this is my bad. Okay, this will be 35, not 30. Okay, so 35 is greater than 25. If this is the case, which is as per the question, then the diagram will be this. Okay, just a theory part that I have explained you. Now let us say that this is the center C1 of the larger circle, this is center C2 of the smaller circle. Okay, let us join these two centers. Okay, so what is the common chord? The common chord will be the line joining the points of intersection of the two circles. Let us denote the points as A and B. So this is the common chord. The line segment joining the points of intersection of the two circles is basically the common chord of the two circles. Okay, now see, this will be 90 degree. Okay, this is also 90 degree. Okay, now this length suppose is P. Okay, this will be AP is equal to PB is equal to X. Say I'm assuming that it is X centimeter. Okay, this is the first thing. Second is they are intersecting perpendicularly. Okay, intersecting perpendicularly. Now you can ask me, right, like why is it 90 degree? So I'll prove both these two statements. There's two statements that I have written here, that is AP and PB are equal to each other. I will prove this one, and I will also prove that this angle is 90 degree. Okay, for the time being I am erasing it. Let's say we don't know, okay, that they are equal, and let's say we don't know that the angle is 90 degree. Okay, so I'll prove it. I'll prove this using the concept of congruent triangles. Okay, you need to know the concept of congruent triangles to prove these two statements. Okay, suppose I join the centers and the points of intersection of the two circles. Suppose I denote this as capital R and this is small r. Similarly, this will also be small r, radii, radius. These two are the radii of the same circle. Similarly, this is also capital R, radii of the same circle, right? So this point is P, right? Okay. If you look at triangle, in triangle AC1 C2 and triangle BC1 C2, okay, BC1 C2, I can say AC1 is equal to BC1. Why? Both are equal to R, right? Radii of the same circle. Similarly, AC2 is equal to BC2 is equal to small r, radii of the same circle again. I mean the smaller circle. And I can say C1 C2 is equal to C1 C2, common side of the two triangles. So three sides are equal, right? The three side of one triangle is equal to the three corresponding three sides of another triangle. That means the two triangles are congruent. So from here, therefore, triangle AC1 C2 is congruent to triangle BC1 C2 using SSS congruency rule. Okay, so now what we can say is that from here we can say, therefore, let us say this angle is alpha, this angle is beta. Therefore, alpha equal to beta. Why is this? Because the two triangles are congruent. If two triangles are congruent, then their corresponding angles are also equal to each other. You can say corresponding angles of congruent triangles. Okay, since this, and what do I mean by congruent? Congruent means identical. Please remember, in short, it means identical, and by identical I mean same size and same shape. Okay, this is the meaning of identical, or you can say congruent. Hence angle alpha and angle beta are equal to each other. Now you might think why I am considering angle alpha and beta, because we have to now prove. Now I will use these two findings, like this finding, like alpha equal to beta. I will use this result. Okay, I will use this result, alpha equal to beta, alpha equal to beta. Okay, I will use this result. Okay, now focus on triangle. Now in triangle AC1P and triangle BC1P, just focus in these two triangles. I have AC1 is equal to BC1, right, is equal to R because radius, right. Then I have C1P equal to C1P, again common side, and I have alpha equal to beta, which I have already used, or like I have already proved there, right. That means what? Two sides and the included angle of one triangle is equal to the corresponding two sides of another triangle and also the included angle between the two sides. So I can say that triangle AC1P is congruent to triangle BC1P using side angle side congruency rule. Okay, side angle side congruency rule. So this side, right, this side is equal to this side. This is the, and this is the common side, and this alpha and beta are the included angle. Okay, that means these two triangles are congruent. If they are congruent, their corresponding sides and corresponding angles will be equal. That means if I look at this AP and PB, from here I will get AP equal to PB, corresponding sides of congruent triangles. This is our first finding, that is AP and PB are equal. Second, let us assume this angle is theta, this angle is suppose phi. I can say theta plus phi is equal to 180 degree because linear angle or straight line. Now since these two triangles are congruent, I can say theta is also equal to phi, right, corresponding angles of congruent triangles. That means what? From here I will get 2 theta, just replace phi by theta, you will get 2 theta, right, equal to 180 degree. So what is theta? Theta is 90 degree is equal to phi. See, I have proven both the statements. That is AP and PB will be equal and they will intersect. It is C1, C2 and AB. These two line segments will intersect each other at 90 degree. So this angle will be 90 degree. Okay, in exam you don't need to prove all this. Okay, you need to you will get accustomed to the results. Okay, you don't memorize also. Okay, just understand the logic and the reasoning behind this. Okay, now I will come back to the question. Now. Okay, see, I can, using Pythagoras theorem, I can write AC1, right? AC1 is capital R, so AC1 square is equal to C1P square plus AP square. I can write it as like this using Pythagoras theorem. AC1 is capital R, right? So capital R square is equal to C1P. Let us say C1P is y square. Okay, let us say C1P is equal to y centimeters. AP we have already taken it as x. So this is our first equation. Can I write this is our first equation. Can I also write AC2 whole square is equal to AP square plus C2P square, right? Again using Pythagoras theorem. Okay, now what is AC2? AC2 is the radius of the smaller circle, so I will write it as r square. What is AP? AP is x square. What is C2P? C2P is, see, we have C1 C2 is equal to 25, right? It is given. Is it 25 or 20? It is 25. Distance between the centers of the two circles is 25. So C1 C2 is 25. Can I write C1 C2 as C1P plus PC2? Same thing, right? C1. What is C1P? C1P I have already assumed it as y centimeters. So what will be C2P? C2P is equal to 25 minus C1P is equal to 25 minus y. So I can write here 25 minus y whole square. This is my second equation. We have two equations and we have two variables, so we can easily find out the values of the two variables. Okay, so I will extend the second equation. Okay, what is smaller? Smaller is 15, right? So 15 square equal to x square plus 25 square. Like this is a minus b whole square. A minus b whole square is a square plus b square minus 2ab. So 25 square is 625. Y square will be y square minus 2ab. So 50y, right? Now you can see I have this x square plus y square. In the first equation, please note x square plus y square is equal to capital R square. So I can say 15 square is equal to x square and y square. I will combine, I will get capital R square plus 625 minus 50y. Okay, or I can say 50y is equal to capital R is 20, right? Yeah, 20. So 20 square minus 15 square plus 625, right? I will use a minus b is a square minus b square. So this will be 5 into 35 plus 625. So 5 into 30 is 150 and plus 25 is 175. If I add the 75 with 625, I will get 700, and I have another 100, so it will give me 800, right? Am I doing any calculation mistakes? So this will be 25, 17, and then I will have 625, right? I will have 800, right? So what will be y? Y will be 800 by 50. All right. So this and this cancels. So 16 centimeter. The value of y is 16 centimeters. What is y? Y is C1P. We need to find the value of x to get the length of the common chord. Now substitute y equal to 16 in the first equation. What is the first equation? We have capital R square, right? Capital R square is, okay, I'll write like this, x square plus y square. So what is capital R? Capital R is 15. So 15 square minus y square, 16 square. Is this possible? I don't, it's not 15, right? 15 cannot be, it's 20, I think. Yeah, my bad, 20. So this is 20 square, my bad. 20 square minus 16 square equal to x square, right? So what will be x? X will be equal to 20 minus 16, which is 4. 20% is 36 under root, right? So I will have x equal to 2 into 6 is equal to 12 centimeters. Please note x is not the length of the common chord. Okay, if I go here, if I go to the diagram, what is the common chord? Common chord is AB. AB is the common chord, right? And AB is equal to AP plus PB, right? Common chord is equal to AB, and AB is equal to AP plus PB. And what is AP? AP is x. What is PB? PB is also x. I have already proved that AP and PB are equal to each other using congruency rules. I have already proved both are equal to each other. So this will give me 2x. And what is x? X is 12. So the length of the common chord will be 24 centimeters. Okay, very interesting question and lots of concepts involved in this question. So is there any option with 24 centimeters? Yes. So the correct answer will be option 1, 24 centimeters. Okay. So very interesting question. I hope this solution made you simpler to understand the question. If you think that this was helpful, please feel free to like and subscribe the video. Thank you.